السلام عليكم ورحمة الله وبركاته. With you today, chemistry teacher Merona Soror STEM منوفية. Our topic today is titration and pH curves. Learning outcome Chemistry Grade 3 13. Know that acid and base equilibria are another form of equilibrium reaction that deserves special mention. Session 4. By the end of this session, the student should be able to 1. Define what is the titration. 2. Draw pH curves. 3. Conclude the type of titrant and analyte from pH curves. Our textbook and resources material. Acid-base titration. What is titration? Titration is a method to determine the concentration of a substance in a solution by adding a solution of known volume and concentration until the reaction is completed, which is usually indicated by a change in color. Titration. This process involves a solution of known concentration, the titrant, delivered from a burette into the unknown solution, analyte, until the substance being analyzed is just consumed. A titration is commonly used to determine the amount of acid or base in a solution. What is a titrant? What is an analyte? Titrant is a solution of known concentration that is used to titrate a solution of unknown concentration. Analyte is a substance whose quantity or concentration is to be determined by a solution of accurately known concentration called a standard solution. What is a standard solution? Standard solution, a solution of known concentration that were prepared before the titration. Acid-base titration curves. The progress of a titration is represented by a plotting the pH of the solution versus the volume of added titrant. The resulting graph is called pH curve or titration curve. There are 4 parts of the titration curve. The first part indicates the pure acid in this point. Buffer region, 3 equivalence point, number 4 excess base region. 1, 2, 3, 4. The initial pH tells you whether the sample is an acid or a base. A rise in the curve indicates that the titrant is a base, as in this part. A decline in the curve shows that the titrant is an acid. Declined. Rise. Start with strong acid, start with strong base. The midpoint of a step change in pH marks the equivalence point. By interpretation, you can obtain the information needed to calculate the concentration of the unknown in an acid-base reaction. There are 4 parts to the titration curve of a weak acid analyte with a strong base as a titrant. The first initial pH of a weak acid, buffer equation, equivalence point, excess base, pH based on the concentration of excess titrant. Equivalence point. It is the point at which the 2 solutions used in a titration are present in chemically equivalent amount. Endpoint. It is an experimentally observed point at which the indicator changes color. What is the main difference between equivalent point and endpoint? Equivalent point, the point in a titrant where the amount of added standard reagent is exactly equal to, is chemically equivalent to the amount of the analyte. Endpoint, the point in a titration where the physical change occurs that is associated with the conditions of chemical equivalence. Volume difference between the equivalence point and the endpoint should be small. This difference in volume is the titration error. As we can see in this graph, so the goal is to have the endpoint and the equivalence point be as close as possible, as we can see from this area, small area. As much it becomes small, the better the titration. Another difference. First graph, titration of strong acid with a strong base. At the beginning, we can see that the titrant is a strong base, the analyte is a strong acid. So the curve starts rising from 2 pH 2 because it is acid and rises up as we said before. In this X is the pH of the analyte solution and this X volume of titrant addition. In this graph, this is a strong acid and this is a strong base, so the equivalence point must be 7. Note, strong acid, strong base titration show a sharp change in pH near the equivalence point. Sharp change, as we can see here. There is a sharp change. Titration of a weak acid with a strong base. Titrant is sodium hydroxide and the acid is acetic acid. The starting point is rises up because it is a weak acid. This is the equivalence point is more than 7 because strong base was weak acid. Titration of strong acid with a weak base. We start with strong acid and added a weak base as we can see. So the starting point is nearly 2 or maybe less than 2. The equivalence point must be less than 7 because it is a strong acid and weak base. Titration of weak base with a weak acid. As we can see, ammonia is analyte, acetic acid is a titrant. The curve is completely changed. It starts from up and moves down. The equivalence point is nearly 7 as they are too weak, acid and base. The strong base weak acid pH curve shows the effect of buffering before the equivalence point. For a strong base weak acid titration, the pH is greater than 7 at the equivalence point because of the basic properties of the conjugate base. Strong base weak acid, strong base strong acid, weak base strong acid, weak base weak acid. This is the 4 curves. We can conclude the difference between them. The main difference is the end point, equivalence point is change according to the changing the analyte and the titrant. In this slide, we can see the difference between titration by replacing analyte with titrant. In this case, strong acid titrated with strong base. We start with acid and the curve rises up. Strong base, at the beginning we start with a strong base, so the curve moves down. The equivalence points of the two is near 7 or exactly 7. In this slide, we take weak acid titrated with a strong base or weak base titrated with a strong acid. It is a strong acid curve, but it is a weak acid curve. This is a big difference between them. In this case, there is a sharp change in the strong, but the change is not sharp in weak, strong. As we can see in the second graph also indicates so. Acid-base indicators. Indicators, they are substances that changes color over a specific pH range. And indicators can exist in either its acid or base form and it changes color when proton gain or loss occur. As example, the indicator phenolphthalein is colorless in acidic solution and pink in basic solution. This is the table of the main important indicators and the titration range. From this we can conclude that bromothymol blue used in titration of a strong acid by a strong base because the equivalence point occur at pH 7. Thymol blue or phenolphthalein when a weak acid is titrated by strong base, the equivalence point is at a pH greater than 7. Methyl orange could be the best choice if your titration used a weak base and a strong acid, because the equivalence point might be at a pH 4. When we use a strong acid with a strong base, the suitable indicator is phenolphthalein or methyl red, and the same in strong base and strong acid. If we have a weak acid by strong base, we can use phenolphthalein. Using weak base and strong acid, we can take methyl orange. For a strong acid strong base titration, the indicators should have a range between 4 and 10. Otherwise, the color change will not happen during the step part of the curve. You will be unable to determine the equivalence point. This is the end of our session today. Thank you very much.